A periodic function is a function whose y values repeat in a pattern. So if you look at this first graph, number 1, if I'm looking at all the y values, this first one would be 0, and then up here it's at 2, back to 0, -2, back to 0, 2, back to 0, -2, back to 0. So you can see that I have the same y values repeating over and over again. For this particular graph, I have to go from 0 to 2, from 2 to -2, and back to 0, and that would be considered one full cycle of the graph. Then you can see I would have another one right here. So this little zigzag shape, each one would be considered what's called one cycle of the graph. If you can imagine taking the blue one, if you slid it over to the right so that this blue dot right here, this first one, linked up right here with this dot where I'm putting that yellow dot, it would just fall right in place. It would just go right over the graph. So you'd be repeating that same pattern over and over again. So the answer for number 1 is that yes, this is periodic. For number 2, if I'm looking at my y values, it looks like we go from 0 to 2, back to 0, and this looks like, I'm going to say -1. And then we go back to 0, but now it only goes up to 1, and then back to 0. So even though, and this doesn't even look like maybe -0.5, so you can see that like this one does not repeat. It keeps getting lower and lower and lower. So if I took this little section of the graph here and I shifted it over, it's not the same as this little section of the graph. They're actually different because their y values are different. So this one is not periodic. For number 3, this one is periodic. And you can do that by looking at those y values like we did before. One thing that is kind of helpful to do, if you start at where x is 0, so right here, and you look at the shape of the graph, and you kind of go until you get back to the same y values. So that would be down here somewhere. You can kind of see that this graph, if I shifted it, now if I went to the left this time, that's the same shape of graph. So if I shifted it over, it would be repeating itself. Another thing I kind of like to think about is if you put in these like imaginary lines at the top and the bottom of the graph, if your graph stays within those lines and it touches at the same spot, so like how it touches up here, it touches it again right here, same thing down here and down here. If you did that same thing with number 2, you put those lines in, you would see that even though it does touch here and here, then as you go on, it no longer touches the line as it's going up and down. All right, now number 4 is kind of a tricky one. This one is not periodic. And even though it looks symmetric, and it is symmetric, if you look at your y values, this one starts with, we'll say 4, and then this is about 3, this is about 2, or actually more, it's more like 3, 2, 1, and then this is almost 0. Now this one, if it was periodic, it would have to start with 3, 2, 1, 0 again, but it goes backwards. It's 0, 1, 2, and 3. So even though this one is symmetric, it's not periodic because I can't take this left portion of the graph right here and I can't slide it over and get the next thing. It doesn't link up with itself. So that one would not be periodic. In example 1, this would be an example of a periodic graph. If you take a look at, I like to just look at starting at when x is 0. If you go up and back down so that you're at the same y value, that is not a full cycle because if I shifted that over, it would give me this, and that is not what the graph looks like. So I need to go down and back up to 0, and this would be one full cycle. So now if you look over here on the left side, that's kind of the exact same thing you see. It's that same shape over and over again. So this one is periodic, so we can say yes, it is periodic, and then it's asking us to identify the amplitude and the period. The amplitude we have that little formula for, which is the top value, the top y value minus the bottom y value. So our top y value would be right here, which is 2, and our bottom y value would be here at -2. And one of the ways that you know that this is periodic is because you can pick that top value or bottom y value from any part of the graph, and it should always be consistent. So our top y value is 2, our bottom y value is -2, and then we're dividing by 2. 2 minus -2 is 4, and 4 divided by 2 is 2. So the amplitude of this graph is 2. So what that means is if I drew a line right in the middle here, and this is actually the midline of the graph, which we're going to talk about in the next slide. The midline of the graph is at 0, and we'll talk about how you get that, like I said, in the next slide. And what the amplitude tells you is that if you start at the green line and you go up to the graph, you're going 2 above, or you're going 2 below to get to the bottom of the graph. So it should be right in the center so that you go the same distance up as the same distance down to get to the graph. So that's amplitude. And now we're going to talk about the period of the graph. So for the period of the graph, I want to look at just the blue part, the part that I highlighted the graph in blue. If you start at 0, which I did, wherever your graph stops repeating itself, so whenever you get through a full cycle, wherever that is, which happens to be right here where I'm putting this big purple dot, that is the end of the period of the graph. So if you look at the labels on the x-axis, they're kind of hard to see because I've written over a lot of them, but this is 1, 2, 3, and so this actually ends at 4. So the period of this graph is 4. For example 2, this is again another periodic function. This one looks a little strange, but if I start at 0, where my x is 0, and I follow this pattern, I have to get back to the same y value. So here I'm at the same y value, and now if I took that pattern and I shifted it over, I would end up getting that same graph. So you can see that same pattern over and over again. So that would be one cycle of the graph. So this, we can say, yes, is periodic. Now for amplitude, we're going to do the same thing. My highest y value, and I can pick anywhere on the graph, would be here. This x-axis is the y-axis is scaled by 2s. So halfway between that box is actually a 3. And then I'm subtracting the lowest y value, which is down here at 0. And you're always dividing by 2. So this would be 3 over 2, which as a decimal is 1.5. So our amplitude is 1.5. And then for the period of the graph, I'm just going to look at the blue portion of the graph because it starts at 0. So it starts at 0 and it stops right here. That would be the end point of that blue section. My x-axis is scaled by 2s, so that would actually be at 6. So the period of this graph is 6. All right, now number 3. This is another periodic function. I'm going to start here at 0 because I think that's the easiest thing to do. I have to follow the graph until I get back to the same y value, which is about right here. And that is one full cycle. Now one thing I want to mention, I want to go back to problem number 1. We talked about how if we went up and came back down to the same y value, the reason that is not a full cycle is because if you repeated just that part of the graph, it does not match with what happens next. So sometimes, like in number 1, you're going to have to go back to that same y value. You're going to have to cross over that y value and come back to it to get a full cycle. And then sometimes, like in number 3, and it also happened in number 2, where you're going to start at a y value and then you'll stop the next time you get to it. You just have to look at the graph to see what you're dealing with. All right, so this is periodic, and you can see it in a couple different ways. Here's another cycle of the graph. So you can see that pattern is repeated over and over again. So I'm going to say yes, that this is periodic. For the amplitude, my highest y value is 2 and my lowest y value is -1. So for amplitude, I would have 2 minus -1 over 2, which is 3 over 2 or 1.5. And then the period of the graph, I'm going to look at the blue portion of the graph because it starts at 0 and then it stops right here. So if I look at my x-axis, the scale is by 1. So this would be 1, 2, 3, and 4. So the period of this graph is also 4. Now my last example here is actually not periodic. And there's a couple different ways you can see it. If I kind of highlight from here, it looks like this would be the next time I get back to my same x value or my same y value. And even if I do this, okay, that kind of gets me back there. But now if I do that same thing over here, that's not the same pattern. They don't have the same y values, so this is not periodic. So that means we don't have to figure out, excuse me. So because it's not periodic, we don't have to talk about amplitude and period. There are 4 things we have to identify in these next examples. The first is the number of cycles between 0 and 2 pi, what the period of the graph is, the amplitude, and then the midline of each graph. So I think the easiest thing to do is to start off with, let's look at the graph and identify one full cycle. So we're always going to start the cycle at x equals 0, so at the beginning of the graph. Okay, now if I go up and back down to the same y value, that is not going to be a full cycle, because if I repeated that, it would be another like bump or a hill, and I needed to go down to a valley. So I know that that's not a full cycle. So I'm going to go back down and then up here. So this to me looks like a full cycle, because now if I repeated that, and I can actually repeat it 3 times, you can see that it's that same little wave happening over and over and over again, and they're all identical. Okay, so what this is, now let's go down to these questions here at the bottom. The first thing it's asking is, how many cycles are there between 0 and 2 pi? Well, this is 2 pi right here. So since I have one blue cycle between 0 and 2 pi, I have one cycle between 0 and 2 pi. The period is however long it takes to get from 0 to the end of your first cycle. So the period of this is also going to be 2 pi, because that's where it stopped. Once you get to 2 pi, you start with the yellow cycle. So that one, you know, it would be a fresh cycle. All right, now the midline and amplitude, those are 2 things we have formulas for. I'm going to do the amplitude first because we've done this already. I'm going to take the highest y value, which it doesn't matter which one I take. I'll use the green one. The highest y value is 1, and then my lowest is -3. So I would have 1 minus -3 over 2, which is 4 over 2, which simplifies to 2. And then I'm going to do the midline. So midline we have not done before. It is always going to be y equals. Amplitude is just a plain number. Midline always has to be an equation. Y equals, because it's going to be a horizontal line. Now, it's almost the same formula as amplitude, but instead of 1 minus, we're going to do 1 plus -3 over 2, which is -2 over 2, and that simplifies to y equals -1. So what that looks like on the graph then, if I put this purple line here at -1, it's going to cut my graph in half. So that means that the graph goes as high above the purple line as it does below the purple line. And that amplitude represents how high and low it gets. So there's going to be a distance of 2 from the purple line to the top of the graph and from the purple line to the bottom of the graph. All right, we're going to do the same thing with number 2. I want to identify one full cycle. So I'm starting here at 0. If I go up and come back down, that is not going to be a full cycle, because if I repeated it, it would not match the graph. So I'm going to have to go down and back up again. So it looks like it's going to stop about there, meaning my new cycle is going to start here. And then you can't actually see the rest of it, but it would, you know, look something like that. Okay, so that would be the full cycle. So it looks like here's 2 pi. So from 0 to 2 pi, I've got that one blue cycle. So the number of cycles between 0 and 2 pi is 1. The period, again, is going to be this number here, which is 2 pi. And now we have to talk about midline and amplitude. I'll do midline first this time. It really doesn't matter. remember that it's always going to be y equals. My highest y value is right here at 1, and my lowest is down here at -4. So I would have 1 minus -4 over 2. I'm sorry, 1 plus, that's the formula, which is -3 over 2, or y equals -1.5. So the midline is actually not going to be on a whole number. It's going to be in between at -1.5. Okay, and then for amplitude, it's the same formula, but instead of a plus, it's a minus. So it would be 1 minus -4 over 2, which is 5 over 2, or 2.5. So on my graph here, my amplitude, if I start at this purple line and I go up, it should be 2.5. And if I start the purple line and I go down, it should also be 2.5 boxes away. All right, same problems as the previous slide. The first thing I want to do is figure out where one full cycle of this graph would stop. So I'm going to start here at 0, and I'm going to go back to the next matching y value. And if you look at this, even though I didn't have to go down and up, this is actually a full cycle, because now if I do this one in yellow, you can see it's that same shape over and over again. And then you can see about half of another cycle, which would end somewhere over here. Okay, so the question it asks us first is how many cycles are there between 0 and 2 pi? So 2 pi is over here. So I have the blue cycle, and then I also have the yellow cycle. Those both fit within 2 pi. So my answer is that there are 2 cycles between 0 and 2 pi. Now the period is asking me, what is the length of one cycle? So I'm going to focus just on the blue one. I want to know at what x value does the blue one stop? So this blue stops right here, which means that the period is pi. Midline and amplitude are going to be the same as they were in the previous slides. I still need my maximum and minimums. So I have my highest y value is at 1, my lowest y value is at -1. So for midline, it's going to be 1 plus -1 over 2, which is 0 over 2, or just plain 0. So my midline is actually at 0, meaning it's it's the same as the x-axis. And then for amplitude, you can actually kind of see it from the graph. If you look, there's one box to go up and then one box to go down. So we should get 1 as our answer, but we'll go ahead and figure it out here. So it's going to be 1 minus -1 over 2, which is 2 over 2, which is 1. So a couple different ways you can look at the graph once you find your midline. You can use this little formula, but your answer should match up. Now this last one is a little bit tricky. Again, I'm going to go through and I want to figure out where one full cycle is. So it looks like I'm starting here, according to my scale, that's at about 1, because it's halfway between that first box, but it's scaled by 2. So if I go up and I come back to 1, that's not a full cycle, because if I repeated it, it wouldn't match up with the graph. So I'm going to have to go down and back up to 1. So that would be a full cycle, and then that would start this full cycle, which you can't see the rest of, but would look something like that. Now this one, it asks me how many cycles are there between 0 and 2 pi. Well, 2 pi is like way back here. The period of this graph, which I'm actually going to skip out of order, the blue part of this graph stops at 8 pi. So that's the period of this graph. I only want to know what portion of it, how many cycles there are between 0 and 2 pi. So I'm only going 2 pi out of a total 8 pi. So to figure this out, this is actually going to be a fraction. What we're going to do is we're going to take the number that we want, the portion that we want, and divide it by the portion of, or divide it by the whole thing. If I reduce this, the pi's are going to cancel. 2 over 8 reduces to 1/4. So this is a quarter of a cycle between 0 and 2 pi. Now the midline and amplitude, these two things are hopefully not so bad. Looks like my highest point is at 5, and my lowest point is at -3. So for the midline, I'm going to have 5 plus -3 over 2, which is 2 over 2, or y equals 1. So I can draw that in. Okay, so that's my line y equals 1. And then you can kind of look and see what the amplitude's going to be, but you can also use the formula. So it's going to be 5 minus negative 3 over 2, which is 8 over 2, or 4. So the amplitude for that graph is 4.